Hi, hello everyone. This is Nepaledi sir from ANR Academy. We are familiar with trigonometric formulae like sine 2 theta, sine 3 theta, and also cos 2 theta, cos 3 theta. But today we are going to discuss how to find the formulae for sine 4 theta, sine 5 theta, sine 6 theta, and so on. In the same way, how to find cos 4 theta, cos 5 theta, cos 6 theta, let us discuss. And this is interlinked with De Moivre's theorem as well as binomial theorem. With the help of these two topics, now let us observe how to find when the multiple angle is large numeral. Suppose that cos theta plus I sin theta whole to the power of n if you have. With the help of De Moivre's theorem, I can write it as cos n theta plus I sin n theta, where n is natural number. This is one result. Next, I am going to write binomial theorem. Suppose, for example, if you have a plus b whole to the power of n, then you know that the expansion nc0 a power n plus nc1 a power n minus 1 b power 1 plus and so on ncn b to the power of n. First one De Moivre's theorem, second one binomial theorem. With the help of these two, now I am going to find first what is sine 4 theta and what is cos 4 theta formula. Let us observe. We are going to find cos 4 theta and sine 4 theta results. Suppose that the value of n, if it is equal to 4, what happens? Observe. Cos theta plus I sin theta whole to the power of 4. That is, with the help of binomial expansion, I can write 4c0 cos theta power 4, next plus 4c1 cos theta power 3 I sin theta, next plus 4c2 cos square theta I square sin square theta plus 4c3 cos theta multiple I cube sin cube theta, and the last term 4c4 I power 4 sin power 4 theta. This is by binomial expansion, and using De Moivre's theorem it is actually cos 4 theta plus I sin 4 theta, and 4c0 value 1, so that first term become just cos power 4 theta. Next 4c1 value 4 here, and then I also is there cos cube theta sin theta. Next 4c2 value, you know the binomial expansion in which binomial coefficients with the help of Pascal triangle 1 1 1 1 2 1 1 3 3 1 1 4 6 4 1. Sum of these two, you will get 2 here, 1 plus 2 3, 2 plus 1 3, 1 plus 3 4, 3 plus 3 6, 3 plus 1 4 here, and the value of 4c2, that is 6. I square value minus 1, 4c2 value 6, so that minus 6, remaining cos square theta sin square theta, and then I cube is nothing but I square into I square value minus 1, so that we get minus 4c3 value 4 cos theta and I sine cube theta, that is. Next I power 4 value, I square whole square, nothing but minus 1 whole square, that become plus 1, and also 4c4 value 1. So final term sine power 4 theta. There are real as well as imaginary parts, and in the left hand side also you have real part as well as imaginary part. Comparing real parts, what we get observe? Only the real parts. Both the sides I am going to compare first, and then imaginary parts. Comparing real part, this one is real, so that cos power 4 theta here I am going to write. This is imaginary, right? So that here I am going to write. This one is imaginary portion, sine 4 theta value. So 4 cos cube theta multiplied by sine theta. Next, this is real part, that is minus 6 times of cos square theta sine square theta. Next, this is imaginary. So here you have to write 4 cos theta sine cube theta, and this one is real part, so that here you have to write sine power 4 theta. On comparing real and imaginary parts, you got the values of cos 4 theta and sine 4 theta. So in this way you can easily find multiple angle formulae when large numerals are given. Let us discuss how to find cos 6 theta in the next. Suppose that the question is, what is the value of cos of 6 theta? Clearly cos 6 theta, that is using binomial and De Moivre's theorems. When you compare real parts, you will get cos 6 theta value. First I am going to write cos theta plus I sin theta whole to the power of 6, that is using De Moivre's theorem, it is cos 6 theta plus I sin 6 theta. Also with the help of binomial expansion, the first term 6c0 cos power 6 theta plus 6c1 cos power 5 theta and multiplied by sin theta, next I sin theta. Next 6c2 cos theta power 4 I square sin square theta. Next term 6c3 cos cube theta I cube sin cube theta. Next 6c4 cos power 2 theta I power 4 sin power 4 theta plus 6c5 cos theta I power 5 sin power 5 theta plus 6c6. The last term we get 6c6 multiplied by I power 6 sin theta whole power 6. To get cosine angle 6 theta, cosine of 6 theta, you have to compare real part. Now I am going to compare real part. Comparing real part, what happens, observe. This is real part, right? So cos of 6 theta. You know Pascal triangle 1 1 1 1 2 1 1 3 3 1. Next 1 4 6 4 1. Next 1 5 10 10 5 1 1 6 15 20 15 6 1. Real parts you have to select from right side, this one and this one. Next this is real, I square value minus 1, I power 4 value plus 1. Next the last term, this one, right? So now I can write cos 6 theta as 6c0, that is 1, Next, cosine angle with exponent 6. Next, 6c2, that is 15. Multiple here, cos power 4 theta, sin power 2 theta, and I square value minus 1, so that here you have to write negative sign. Next, 6c4, that is 15, and cos square theta, sin power 4 theta, that is with plus sign. And I power 6 value, I power 6 written as I square power 3, that is minus 1 whole power 3, it become minus 1, so that you will get next minus sign. 6c6 value 1, I power 6 value minus 1, and remaining sin theta power 6. So it is very clear that to get cos 6 theta from Pascal triangle, here the coefficients you have to write first, third, fifth, and then seventh binomial coefficient. Here the binomial coefficients 6c0, 6c2, 6c4, and 6c6. So alternate terms you have to write as coefficients, and also they are with plus or minus sign. When you have cos 6 theta, then the first term with cos theta power 6 you will get, and here to the next and next terms the exponents are reduced by 2 units. Remember, here it is cos theta power 6, and the next term you will get cos theta power 4, and then cos square theta, after that cos theta power 0. And the sign exponents are increases with the 2 units. This is sin theta power 0. There is no term nothing but sin theta power 0, and then sin square theta, sin power 4, and then sin power 6 theta. Next, to get sin of 6 theta, you have to write imaginary parts, right? To get imaginary parts, you have to write binomial coefficient 6, 26 with alternate plus minus symbols. So 6 first, and then minus 20, after that plus 6. So first write the coefficients with alternate plus minus symbol using Pascal triangle. When cos 6 theta, when cosine angle is asked in the question, then write first, third, fifth, and the last seventh binomial coefficient. Whenever sign is given in the question, then second binomial coefficient, fourth, sixth binomial coefficients with alternate plus minus symbols we have to write. And here when you have sin 6 theta, here cosine angle you will get 1 unit less, and sin raised to power 1. Next, 2 units difference, that is cos cube theta, sin power 2 units difference, so that you will get sin cube theta. And then last term, cosine angle whose exponents are reduced by 2, so cos theta power 1, and sin angles whose exponents are increased by 2, so sin square theta. So this is the formula to find cos 6 theta and sin 6 theta. Now in a simple way, let us write sin of 8 theta cos of 8 theta. One, I am extending Pascal triangle. 1, 7, 21, 35, and then 35, 21, 7, 1. Next, 1, 8, 28, 56, 70, 56, 28, 8, 1. See, suppose if you need to write cos 8 theta value, and then we go for sin 8 theta. First cosine angle and then sine angle. Cosine you will get by comparing real part, and sine angle on comparing imaginary part, you know this. So for cos A theta, you have to write binomial coefficients. These 5, 1, 2, 3, 4, 5 binomial coefficients alternate with plus minus symbol. So plus 1, next minus 28, and then plus 70, and then minus 28, and after that plus 1. Okay, let us start this with cosine angle whose exponent is 8. When you have 8 theta, here start with 8, and then reduce cosine angle whose exponent reduced by 2 units, and sine angle whose exponent increased by 2. Next continuation, cos theta power 4, sin theta power 4. Next cosine angle reduced by 2 whose exponent sine angle increased by 2, so that 6 here, and then the last term sin theta whole to the power of 8 we get. So in this way, just by seeing Pascal triangle, you can write cos 8 theta formula. Okay, now let us discuss sin 8 theta. Remaining binomial coefficients with alternate plus minus symbols, you have to write. They are plus 8, and then minus 56, after that plus 56, and then minus 8. Here if you have cos 8 theta, the first term cos theta power 8. When you have sin 8 theta, cos theta whose exponent 7 and sin theta whose exponent 1. Let us start like this first, and then raise sin exponent 2 units and decrease cosine exponent 2 units, and continue this, you will get the result. That is cos theta power 5, sin theta power 3, and then cos theta power 3, sin theta power 5, and then here cos theta power 1, sin theta power 7. So this is the way of calculating sin 8 theta and cos 8 theta. Just with the help of Pascal triangle, I am going to write the two formulae. So this is the procedure to write multiple angle formulae in terms of sine and cosine, and clearly it is interlinked with binomial theorem as well as De Moivre's theorem. So in this simple manner, you can create any formula, any large multiple you have, you can easily create the formula. Thank you so much, and we will continue in the next session. Thank you.